So, what if I told you that building a really powerful AI system isn't about creating some single, all knowing genius? What if instead it was a lot more like building a factory? A fully automated assembly line, but instead of robots, it's staffed with specialized AI workers, each one an absolute expert at its own little task. Let's dive in and see exactly how you can build an AI assembly line just like that. All right, we're going to tackle this in four main stages. First, we'll lay down the strategic blueprint, the master plan. Then, we'll get our hands dirty and choose the right tools for the job. After that, we'll actually assemble our team of specialist agents. And finally, we'll walk through the whole process of launching the entire system into production. Any great engineering project, whether it's a bridge or a skyscraper, starts with a solid plan. And for our AI assembly line, this is, without a doubt, the most critical part. This is where we figure out the entire purpose and scope of our operation before we even think about writing a single line of code.
So why do we even need a whole assembly line? I mean, why not just one big AI? Well, the old way of using a single generalist help bot, it's just prone to errors, and it gets super complex to manage really, really fast, especially for high-stakes tasks like, say, regulatory compliance. A multi-agent system, on the other hand, it breaks the problem down. Each agent is a specialist, which makes the whole system way more accurate, a heck of a lot easier to manage, and just far, far better at its very focused task.
No, you can't just unleash an AI worker and tell it to do the right thing. That's a recipe for disaster. You need to give it a thinking process, and that's what we call a logic pattern. This basically forces the AI to reason things out in a structured, step-by-step way before it takes any action. And let me tell you, that is absolutely crucial for making sure it's accurate and reliable.
To get started, you've really got two core patterns to work with. First is plan and execute. The agent literally maps out its entire course of action before it does a single thing. This is perfect for predictable tasks where all the steps are already known. But for more dynamic problems, you've got REACT, which stands for reason and act. It's this continuous loop where the agent thinks, acts, sees what happens, and then adjusts its plan. Both are super powerful, but the real key here is to start simple. That way you maintain control and you ensure accuracy. Okay, so we have our blueprint. We know how our agents are going to think. The next big question is, what do we actually use to build this AI factory? What tools do we give our workers?
Well, this is where the Google Agent Development Kit, or ADK, comes into play. Just think of it as the central operating system for your entire factory floor. What's so great about it is that it lets you treat building these AI agents just like you would traditional software development. You can use common languages you already know, like TypeScript, Go, or Java, which gives you a ton of flexibility. And this is where it gets really, really powerful. See, you're not just giving the agents a brain, you're giving them a whole toolkit. They can use Google Search to stay totally up to date on new regulations. They can query your company's internal data with BigQuery. They can even assess your cloud setup using custom AWS tools. Plus, you can give them memory, both short and long term, and enforce really strict data rules to prevent hallucinations and errors. We have the plan and we have the tools. Now it's time to hire the crew. This is the heart and soul of our AI assembly line, the automated workforce of highly specialized agents. Just look at how this division of labor works. Instead of one agent trying to juggle everything, we have specialists. You've got the framework architect, who's an expert at translating dense regulations into concrete business rules. Then there's the policy writer, who excels at creating perfect formal documents. And the technical auditor. Its one and only job is to assess cloud configurations. Each one is a true master of its craft.
So how do they all work together without tripping over each other? That's the job of the coordinator. You can think of it as the foreman of the factory. It understands the big picture, the overall task, and it uses its intelligence to route the work to the right specialist at exactly the right time. It makes sure there's a smooth, seamless handoff from one station to the next.
Okay, our assembly line is built, and the workers are all trained up. But we can't just flip the switch and hope for the best. Nope. This final phase is all about making the system reliable, safe, and ready for the real world. This is about professional-grade deployment. And that requires a really disciplined life cycle. You have to systematically evaluate everything the agent does. You need to monitor it all, latency, errors, any tool failures, so you can catch problems early. Security is obviously paramount, especially when you're dealing with sensitive data. And this one is crucial. You have to treat your agent prompts just like you treat your code, with version control and the ability to roll back if something goes sideways. And finally, you've got to get it out there. You can package the agents using Docker for consistency, deploy them on scalable cloud infrastructure like Vertex AI or Cloud Run, and integrate their work directly into your products, whether that's through a web app or an API. This is exactly how you go from a cool prototype to a scalable, enterprise-grade system. So here's the bottom line, the crucial point to take away from all this. We're shifting our thinking. We are no longer trying to build a single AI that can somehow magically build an entire car by itself. Instead, what we're doing is building a series of specialized robotic stations, those are our agents, each one programmed with specific tools to perfect one small part of the process. And that creates a far more powerful and reliable result in the end. Look, this isn't just some abstract theory. It's a practical, real-world framework for automating complex, knowledge-based work. So the only question left is, with your own AI assembly line built and ready to go, what are you going to create first?